Good morning, and thanks for taking the time to look at PrivacyWatcher. In the next few minutes, I will show you how it works, control, why we are in the latest 3.5.1 release, what is focused on, the evidence quality, and of course the operational transparency. We have 30 slides, let's begin. We have the system context. PrivacyWatcher is designed as one of evidence workplace connected to multiple controller services. The public side show only evidence gate information, dashboard, timeline, company view, and policy signal. The admin side manage retrieval, review, dataset quality, and VPS operation. The platform map policy evidence, record how that evidence was obtained, and expose only what can be pointed out. The next slide, we have the deployment topology. The system runs across two main environments, the host and the application for the public interface, and separated the VPS as companion services, especially for the render used to standard HTTP retrieval services when they are not enough. The separation is of course intentional, because public view, admin authority, dataset persistence, and browse-based retrieval are coordinated, but they remain distinct operation zones. 5 retrieval strategies, 1 evidence decision. This is the ingestion cascade. The ingestion pipeline followed by controlled cascade. It starts with the direct retrieval, then HTTP2, then the VPS render, and only after the retrieval sources as the wayback machine or the common crawl. Each step records why it succeeded, failed, or escalated. If no strategy, returns substantive policy text. The source is suspended rather than just exposed as reliable. This is the core principle of the release. Only data can be validated, not just silent assumptions. Slide 4. Let's move faster. The evidence gate, before anything becomes public, it passes through an evidence gate. Source must have an executable test, a valid retrieval path, the context late, a stable final URL, and upsettable data status. Seated or unsettled records are blocked since the beginning from the public branch. This protects users from seeing placeholders, incomplete retrieval data, or demo, or just data not trusted by the clear evidence. The baseline workflow is one of the most important safeguards of the baseline workflow. When I see that the record is replaced by real source text for the first time, PrivacyWatcher doesn't create just a placeholder policy change. It stores retrieval text as first verified baseline. Only later differences against the verified baseline can become a change events. This avoids false or incorrect alert and preserves historical integrity. The dataset quality assurance loop. Dataset quality is treated as a process, not just like an add-on. The system continuously checks source availability, retrieval method, freshness, anomalies, and review status. The source is moved into review state. The admin can inspect the issue, export QA data, remedy the URL, or just keep source suspended. Dataset is admin VPS operation. We see later in the hands-on. The admin panel is the operational control room. It includes the Chrome Manager, dataset Q&A, KPI audit, company registry, access log, VPS service monitoring. From there, the administrator can trigger controller scan, check rendered health, run smoke test, and inspect service status. The render operation agent remain external services, but they are monitored from the same governance interface. Moving to the slide 8 about the data model. The data model is built around evidence lineage. Companies have policies, policies have snapshots, snapshots can generate policy changes. Around the chain, the system record check log, review log, regional impact, KPI assessments, and access events. This makes the platform auditable. Each public signal should be traceable back to the policy source and the retrieval method and the storage value state. Slide 9, security boundaries. PrivacyWatcher is also separate trust boundaries. Public users can inspect evidence gate output, admin can operate, scan, and review data. The retrieval layer handles external source trust hardware control, including URL validation and safe error handling. VPS secrets and record credentials stay server side. This is not just a technical detail, it is part of making the platform safe to operate in public. Slide number 10 about the KPI lifecycle. KPI lifecycle assessment. The KPI metric doesn't start from assumptions. First, there must be verified baseline. Then a policy can be assessed across defined dimensions such as data collection, sharing retention, deletion, cross-border transfer, AI opt-out, and algorithm transparency. If the baseline exists but the assessment is not completed, the system shows the pending state instead of filling the metrics with, of course, just placeholder values. Slide 11, correlation metrics. This slide shows an important design idea. The same evidence chain supports multiple views. The dashboard, timeline, report, CSV export, and Dart are not just separate stories. They are different projections of the same underlying evidence. They reduce inconsistencies and make changes to explain how the public insight was produced. Let's move forward. Unified evidence flow. You can see the evidence journey from the policy source to the public view. Document is retrieved, is checked, is stored, is reviewed. The baseline is defined, pass trust, an evidence gate, and then assessed. Only after this step can it support public dashboard or admin review. This is operation health and the main change of the latest release as the confidence one. The last slide for the presentation before a quick hands-on is a control and trust map. This slide summarizes how the runtime, operation, and trust zone work together. For example, the application database are hosted somewhere, the VPS support browser rendering, operation recovery, the admin control plan survive scan, Q&A, remediation, and access log. The public workspace receive only evidence gate output. This architecture is what allows PrivacyWatcher to remain transparent, cautious, and useful at the same time. To conclude, PrivacyWatcher today is not just a policy change monitor, it's becoming an evidence-oriented tech platform processing how major digital companies communicate change in privacy, AI, terms of services, data commerce, and which one are the related impact on the both people and corporate. The goal is to release it simple. When a platform shows something, it should be possible to explain where it came from, how it was retrieved, what confidence state it does, and why it is visible. Question feedback are of course welcome. Thanks.